Hello and welcome to MTD TV. Today we're going to be exploring the minefield that is spindle nose tooling. Neil, thanks for joining us. What are we going to look at?
Okay, what we've got here is a variety of applications of spindle nose tooling. These are a BT spindle, but this is a face mill adapter, your standard thing for your indexable tool holders milling. Then we've got our own, what we call a Mega E collet chuck, which we put up against ER collets and so on for milling and drilling. Two sizes there, and then what we've got is a HMC chuck for heavy roughing. Okay,
if we start with the face mill adapter.
Yep.
You know, the face mill itself isn't going to be accurate, is it? The pockets are going to be machined within,
that's right,
let's say,
sintered inserts.
Yeah, that's sintered inserts, which have got, you know, an error on. The pockets themselves, probably 10 microns. Yep. So just for the viewers at home, what's the point in having such a, you know, such a valuable tool holder?
Okay, I think to answer that, we have to go into what the tool holders offer. These are what's called a BBT spindle. So this denotes it's a big plus system. In the correct spindle, a big plus spindle, you get absolute face and taper contact. This is total taper contact and a face contact on the front of the spindle. Normally, with a normal BT, there's a gap between the tool holder and the spindle face. That, when you're heavy roughing, whether you like it or not, will move. And this eradicates that.
So what's the advantage?
The advantage of that is that you're not any kind of vibration that you get with carbide, whether it be indexable, solid. Two things kill carbide in my opinion: wrong speed and vibration. Anything we can do to get rid of that means we can run at a higher feed rates and get more stable cutting parameters.
And I noticed the nut. That appears to be ground as well. Why is this?
Yeah, the threads are ground internally. Everything on these collet chucks are hand checked for run out. On these two particular here, they guarantee a 3 micron run out at 4 times diameter, whether it be a mill or a drill.
Okay, and a similar scenario on the high performance chuck.
Yeah, that's a roughing tool, but still that achieves a better run out than you get from a standard ER collet setup, even though it's for roughing.
So if for roughing, where's the advantage? Is it down to tool life again?
Tool life and the fact that it's held in a much stronger position. The standard collets that we have are a 12 degree, whereas standard ER collet is an 8 degree. This means that you hold on much more of the tool.
So what would you say to the people who invest tens, if not hundreds of thousands of pounds on a machine tool, and they go and put cheap tool holders in?
Okay, well, everything's made to a tolerance. Us as engineers understand that. As I've said, the tooling that we have here, 4 times diameter, 3 micron run out, guaranteed. However, even on more cost-effective tooling, say a side lock holder, you're doing nothing but asking for a run out. There's bolts on one side of the tool, etc., etc. In tests that we did on standard BT holders on a spindle, we're looking for a taper contact because the standard doesn't have the face contact as well. On tests that we did, we found anywhere between 20 and 40% contact, that's all. So if you imagine when you're putting side load on anything like that, it's going to move within the taper. With ours, we guarantee if your machine spindle is manufactured still in spec, we guarantee 80% contact on a standard BT or DV taper.
Okay, I asked that question, and that's the answer I was expecting. But it's incredible how many people they'll go and spend a fortune on a machine tool. Yep. They'll look saving pennies on the tooling. They want the best tooling they can get. Yep. Oh, I need a tool holder, you know, and they just open up their whatever the brand catalogue is, and it might be for £100 or whatever. It doesn't make sense, does it? It
can't do, can it? I mean, as I say, we're all precision engineers. We're all trying to manufacture a cost-effective and first-time, right-time situation. It can only inhibit you.
So we've talked a lot about run out.
Yep.
But how balanced are these tools?
Okay, as a company, Big Die Shower don't actually print a balance to G measurement. They don't believe in it as a practice. They think there's too many variables in the way that it's measured. What they do is they guarantee a run out to a maximum RPM. So
in conclusion from today, what sets you apart? You know, why are people going to buy these instead of the other 25, 30, 40 brands available?
It's down to quality, it's down to contact, and it's down to run out. We will guarantee an improvement in the process, changing to either the Big Plus system or even just a standard BT, purely because we're that confident in the contact on the spindle. To that line, we have a piece of measuring equipment on order which we're getting in November, which is a laser run out reading machine, which we can put directly into a customer's machine, feed it across on the table, and it will give it down to a micron run out reading of what their current setup is. And I will gladly put our tools in against anybody's and prove out the 3 microns at 4 times diameter.
Great, it's a great range. I see a lot of these around as we do our travel, so I'm sure I'll continue to do so, and thanks for coming in today.
No problem, thank you.